Abstract Enum class using ABCMeta and EnumMeta. Simple example. The goal is to create an abstract Enum class through a metaclass deriving from both abc.abcmeta and enum.enummeta. For example, now, on Python 3.7, this code will be interpreted without error. On 3.6.x and presumably below, it will not. In fact, everything looks great. Our row shows be derived from both A and Enum. Abstract Enum is not abstract. However, even though b.foo has not been defined, we can still instantiate b without any issue, and call foo. This seems rather weird, since any other class that derives from ABCMeta cannot be instantiated, even if I use a custom metaclass. Question? Why does a class using a metaclass derived from EnumMeta and ABCMeta effectively ignore ABCMeta, while any other class using a metaclass derived from ABCMeta use it? This is true even if I custom define the _new_ operator. I'm rather confused. Since this seems to fly in the face of what a metaclass is, the metaclass should define how the class is defined and behaves, and in this case, defining a class using a metaclass that is both abstract and an enumeration creates a class that silently ignores the abstract component. Is this a bug, is this intended, or is there something greater I am not understanding?
As stated on at Chetna's answer, what is going on is that EnumMeta class overrides the normal metaclass _call_ method, so that an Enum class is never instantiated through the normal methods, and thus, ABCMeta checking does not trigger its abstract method check. However, on class creation, the metaclasses _new_ is run normally, and the attributes used by the abstract class mechanisms to mark the class as abstract to create the attribute _abstract methods _ on the created class. So, all you have to do for what you intend to work, is to further customize your metaclass to perform the abstract check in the code to _call_. This will make the B1 expression to fail with the same error as abstract class instantiation. Note, however, that an Enum class can't be further inherited anyway, and it's simply creating it without the missing abstract methods may already violate what you want to check. That is, in your example above, class B can be declared and b.x will work, even with the missing foo method. If you want to prevent that, just put the same check in the metaclass _new_. Unfortunately, the ABC abstract method check in Python seems to be performed in native code, outside the ABCMeta._call_ method. Otherwise, instead of mimicking the error, we could just call ABCMeta._call_ explicitly overriding super's behavior instead of hardcoding the type error there.
Calling an enumerated type doesn't create a new instance. Members of the enumerated type are created immediately at class creation time by the meta class. The _new_ method simply performs lookup, which means ABCMeta is never invoked to prevent instantiation. v1.foo works because, once you have an instance, it doesn't matter if the method was marked as abstract. It's still a real method, and can be called as such.